Hello, just going to go through this paper then on some kinetics. First thing they've asked me to do is draw liquid and gas. So I've got my solid done, nice regular arrangement. Think of people out in a fire drill or the exam, nice rows and columns. Liquid then, got to make sure they're touching, but it's not that regular arrangement now. And then finally gas, they're not touching and we need to show they're moving in different areas. They've then asked me to work out which row of the table is correct for water compared to steam. Well, I've annotated that to show that water is a liquid and steam is a gas. Density of water is bigger because my particles are closer together and therefore the water molecules are closer together. Okay. Next question is the student investigates the density of a copper block and the density of a small stone. Student calculates the volume of the block as 13 centimeters cubed and she finds that the mass is 100 grams. Calculate the density. All I've got to do here is substitute in to this equation they've given us. So I'm going to put my mass 100 on top, my volume 13 on the bottom. So 100 divided by 13, and that's going to give me 7.69 grams per centimeter cubed. My next bit then is that the problem with the stone is that it doesn't have straight sides. So describe how a student could measure the volume of a small stone. You may use a diagram if it helps. It doesn't necessarily help, but I've drawn one. We're going to have a measuring cylinder with water. Okay. My first thing I'm going to do is record the initial volume. So say I put 20 in there, I'm going to write 20 down. I'm then going to drop my stone in and then look at how much it goes up by. So I'm going to record my final volume. And then I'm going to calculate my change in volume because that change is going to be equal to the volume of my stone. So those are my 3 marks, 3 steps for calculating the volume of an irregular object. Next question then. Kinetic theory describes the movement of particles in the 3 states of matter. Gas is one of those states of matter, name the other 2, solid and liquid. Complete the sentence by putting a cross in the box next to your answer. The average kinetic energy of the particles in a gas is directly proportional to, it is C, the temperature of a gas in Kelvin. This links quite nicely to Miss Saint's topic on rates in chemistry, where you know at a higher temperature things move faster. Kinetic energy is about movement energy. Okay, so if I'm moving faster, I've got more kinetic energy. The photograph shows an oxygen cylinder that can be used in an ambulance. Part 1, explain how particles of oxygen gas exert a pressure. So first thing is that the gas particles are constantly moving. They collide with the canister and exert a force. I'm then going to go through this little section. This cylinder can release 340 litres of oxygen at a pressure of 101,000. The inside volume of the cylinder is 2.5. They've given me a gas equation here to use. Okay, so what I'm going to do, my initial pressure is 101,000. My initial volume is 340. My final volume 2.5. I've swapped those in for that equation, which I've written here. I've then plugged in all of those numbers, and I get a pressure of oxygen to be 13,736,000 pascals. A student then investigated how the volume and gas and pressure of a gas were related. Use the graph to complete the table. Well, I've got to do some along the corridor and up the stairs, or vice versa. So my first one, I've gone to 2.5. Gone up to hit the curve, gone along and found the volume to be 10. My next one, I'm going to go to a volume of 14, go along the corridor till I hit the curve, and then I'm going to find my pressure to be 1.6. Notice how I've continued on the curve, and that I've only done that here because that helps me on the next question set. Okay. The results were taken at a constant temperature of 23 degrees. Complete the sentence by putting a cross in the box next to your answer. A temperature of 23 can be written in Kelvin as, remember to go from degrees centigrade to Kelvin, we're going to add 273. So I've done 23. Done 23 plus 273 gives me 296. The next thing is estimate a value for the volume when the pressure becomes 4. That's why I continued my curve. So I'm going to continue the curve on, go to 4, up to the curve and go across, and it gives me on my curve a value of 4. Okay, so you've continued that curve, go to 4, go across and find your volume. We've then got a nice little combined gas law question again. So when the pressure of the gas is 2.2 kPa, the volume is 10.8. Calculate the volume of gas when the pressure is 0.2. Initial pressure P1 2.2, final pressure 0.2, initial volume 10.8. We don't know final volume. Swap these numbers for this. So I'm going to get 2.2 times 10.8 divided by 0.2 gives me 118.8 centimeters cubed. The diagrams show a block of solid copper and some oxygen gas in two closed containers. The oxygen exerts a pressure on the lid. The copper does not exert a pressure on the lid. Explain using kinetic theory why the oxygen exerts a pressure on the lid but the copper does not. I've divided my 6 marker into two. 1/2 for oxygen, 1/2 for copper. So I'm going to have to make 6 marks in total, 3 points for each. So for oxygen, I've got the gas particles moving freely. I've said the particles can collide with the lid and therefore exert a force on the lid, and then this leads to a pressure being exerted due to the force on lid. My copper is a solid, which means the particles are fixed. The particles only in contact with the base, therefore cannot exert a force on the lid, and that means that no pressure is exerted as there is no force. So 3 points. Don't worry if you didn't connect them up. I've just done 6 bullet points. Figure 2 shows a tank for holding water. The tank has sides of 2.4, 2.1 and 1.5 meters. We need to be very careful here of which of those we look at. They've given me a little clue so far. I'm going to point that to you now. The pressure at the bottom of the tank is 12 kPa. So I've written that on there. And I'm looking at that shaded area. First thing is state an equation relating pressure, force and area. Well, pressure is force over area, and I've used all 3 of those variables, so I've got that one correct. They then asked me to calculate the weight of water. Well, weight is a force. And to calculate a force, if we look just at the beginning, I had the pressure, but I didn't have the area yet. So I've got to calculate the area. Now we're talking at the bottom. So what I've done is I've taken the measurements of the bottom, I've put in them here. So I know at the bottom that on the side, it was, or on the width, sorry, was 2.4 and the length was 1.5. So I've got them there. So to find the area, I do base times height, 2.4 times 1.5 to give me 3.6. I can then start calculating force. So I'm going to write my equation again. Pressure equals force over area. I'm going to substitute in my numbers. My pressure is 12 and my area is 3.6. So 12 equals force over 3.6. To get force on its own, I've shown with red, I need to times by 3.6. So force equals 3.6 times 12, which gives me 43.2 newtons. Complete the sentence by putting a cross in the box. Kinetic theory describes gases as particles that B. do not move at absolute zero. The apparatus shown in the diagram is used to investigate how the volume of a gas changes with temp when its pressure is constant. Explain how the particles in a gas exert a pressure. Point 1, particles collide with the syringe. Point 2, each time they collide they exert a force and therefore a pressure. The results from the investigation are given in the table. Fill in the gap in the table. For this, I'm just looking for any sensible number between 298 and 348. So I'm just going to put 315, okay? Anywhere in the middle is fine, okay? Describe what the line of best fit shows about the volume of the gas varies with temperature. It's a straight line which is going up, which means as temperature increases, volume increases at a steady rate. And last question, when the temperature of a gas is 298 K, the volume of the gas in the syringe is 6.5, okay? Calculate the volume when its temperature is increased to 450. Right, T1, initial temp is 298. V1, 6.5. Calculate the volume, so V2 is unknown. T2, 450. I've taken those three numbers, put them into the equation. Be careful. Notice how T2 is on top and T1 on the bottom. So V2 equals 6.5 times 450 divided by 298, which means V2 equals 9.82 mil. Well done for sticking with it and watching the video and completing the paper. Make sure that you've uploaded all your work via Teams so I can see that you've completed it, please. If you've got any further questions, put something in the chat on the team or send me an email. Okay, have a good rest of the day and a good rest of the week. Bye-bye.